Hello, this is Rick from MathX, and today we'll be going over number 22 from the 3rd 4th grade Math Kangaroo. Now, since we're dealing with number 22, and this is on the 3rd and 4th grade test, that means after this test, you only have to solve 23 and 24, and then you're done with the test. So that would mean that number 22 would be one of the more difficult problems. However, if we go through this problem, you'll see that that's not the case. Lots of Math Kangaroo problems require you to think outside the box and use unusual solving methods. However, this one, if you just go through the way the problem's intended for you to go through, you're going to get an answer without any creative thinking. So that's what I'll be doing today. I'll show you how, if you just go through the problem step by step using the clues given to you, you'll be able to solve this problem with relative ease. So without further ado, let's just get straight into it. The large rectangle is made of a number of squares of various sizes. The three small squares each have an area of 1. What is the area of the large rectangle? So the question gives us a diagram, and it tells us that the entire figure is made of squares. It also tells us the area of these three little squares here that hopefully you guys can see. And it tells us that each of these has an area of 1. So the first useful thing to note about this is just to recall how to find the area of a square. A square has the same height and the same base, and to find the area of any rectangle, you typically have to do height times base. However, since those are both equal in this case, we can just express the area of a squared as s squared. So the area of every square in this diagram is just the side length of the square squared. So if we apply that to our smallest squares, which it tells us have an area of 1, well, in this case, the area would be equal to 1. So if the area is equal to 1, in order to find out the side lengths of these tiny little squares, we just need to plug it into the equation. So if area is 1, we get that s squared is equal to 1. And then just by taking the square root on both sides, we get the side lengths also 1. So we know the side lengths of each of these teeny squares. The side lengths of each of these teeny squares is 1. So all three of the side lengths of these teeny squares coincides with the side length of this bigger square. And since each of these sides is 1, that means this bigger square has a side length of 3. So if we plug it into this equation, we can get the area of this square by doing 3 squared. Now 3 squared is 9, so we get the area of this square to be 9. And then we see that this square and this teeny square right here share a side with this square to the right of them. We've established that this square has a side length of 3 and that this square had a side length of 1. So if this part's 3 and this part's 1, this total side would be equal to 4. Plug it into our formula, square it to get the area. 4 squared is equal to 16. So we get that the area of this square is going to equal to 16. Now we have a square above that. We've established that the side length of this square is 4 and the side length of this square is 3. And since both of these sides make up the bigger side of the bigger square, we just need to add them up to get the side length. So 3 plus 4 would give us 7. So if we just square that, we get the area of this larger square. So 7 squared would give us 49, so that's the area of this larger square. Finally, to find the area of the final square, and then add all these up to get our area of the figure, we just take that the side length of this 49 square is 7, and the side length of this square with area of 16 is 4. We get that this part is 7, this part is 4, so the total side length of the largest square is equal to 11. So in order to find its area, we need to square that once again. 11 times 11 is 121, so the area of the largest square is 121. So in order to find the total area of this figure, we just need to add up 1 plus 1 plus 1 plus 9 plus 16 plus 49 plus 121. And if we do that, we'll see that 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 9 is 12, 12 plus 16 is 28. So this entire part is 28. And then I just like to group things that end in 9 and 1 together. So 49 plus 121 would give us 170. And we just get their total sum to be 198, giving us an answer of D. So in this problem, we didn't really think creatively at all. We just exploited the simple area formula and just practiced that and just repeated that a bunch of times. So in this problem, we just had to start from the beginning of the problem and just do what the problem wanted us to do. The problem gave us two clues, and if we followed them from the very beginning, we solved the problem. So this shows on other problems where they give you a couple of clues, be sure to use all the clues provided to you, because the problem was intended for you to solve it using most of its clues, or if not all. So in the future, if you see a problem with information, which is all problems, just remember to use every bit of info in the problem. And if you don't, well, then you're going to have a little difficulty in trying to solve that problem.